My name is Peter Detender. I'm a Microsoft technical trainer from Redmond, Washington. I've been a trainer for a bit more than 14 years, but within the Microsoft role, closer to 5 years now. The trainings that I typically deliver are Azure architecting, developing together with DevOps, and now moving more to AI and Copilot. In session 3, we'll cover the comparison of model optimizations. We'll walk you through how to compare the models, distinguishing between them, and how to find out what model is more optimized for specific solutions in your area. Let's get started. Awesome. So looking back for a little bit, we're now jumping into section 3, the last one for today, but we already did a lot of things. We started with understanding Azure AI services, implemented AI Studio, deployed hubs, deployed projects, integrated our models, and then eventually fine-tuning them a little bit. Now from here, we have almost everything in place to really take it to our production-ready custom Copilot. But we're not exactly there yet. There's a few last things that I want to make sure you can grasp from here, and that's our optimizing our models. Because we tested them in the playground, and I hope the examples are already giving you a couple of ideas how you can integrate chat functionality, for example, into your own applications. But they might not be valid for all customer or application scenarios. And that's really what this last section will cover. So when we talk about optimizing our custom Copilot solution, it's really about improving the model. Now, as you can see here, the slide is called Improving the Model Performance, which I think is sometimes a little bit misleading. Now, why is that? Because looking at myself with an infrastructure background from years ago, when I see the word performance, I think about speed. Like my server is not performing fast enough, right? And that's not always what we're talking about in our model context. Now, there's a couple of different ways to optimize the model. The first one is optimizing for context. What it means is that we talked about groundedness before, and what we're trying to do is really giving enough information, technically a data set, to set boundaries like, hey, my dear AI engine, my large language model as the solution in between, you are allowed to answer specific questions, but you're not allowed to expose all information. I want you to limit the answers to my custom data set, like my travel agency example that I'll walk you through in some of the other sections in the next day of this training. So starting at the left down option here is prompt engineering. What is prompt engineering? It's where I would say out of Microsoft, we actually like to describe it as prompt artistry. Now you might think about prompt engineering. Is it really that hard? Do I need to be proficient in becoming a prompt user, a prompt formulator, if you want, because you're really asking questions, defining sentences, right? And based on the quality of your input, the better the quality of the output should be. So prompt engineering allows you to define some mechanisms, and I'll show you later in the playground how that actually works, where I briefly mentioned the system prompt. Now, what you can do with a system prompt is defining what kind of persona, what kind of functionality, but also what kind of context category am I giving to my large language model. Like, you can only answer questions about the weather. If I would ask a question like, hey, my dear AI chat solution, can you provide me a description of Azure AI services? It will tell you like, oh, I'm so sorry, but I'm not allowed, or I cannot even give you that answer because I'm not skilled on that specific context. So that's what prompt engineering is doing. There are a few other ways to manipulate besides the system message, where you can define context as part of the prompt. So I could go like, well, can you tell me what the average summer weather looks like in Seattle? Defining that keyword summer and obviously the location Seattle, it's setting the boundaries. It's not going to give me the average weather for the whole year. It's scoping it to summer. And the cool thing is, again, obviously, that the large language model recognizes, thanks to the natural language processing, it knows what summer is. So that's where you can define, I would say, the boundary setting the scope of your prompt. There's a few more examples that I like to show you later on in a demo how it works. On top of prompt engineering, you can expand with Retrieval-Augmented Generation, or in short, RAG, as we call it. So in short, what we're doing with RAG is bringing in your own custom data set. We have a dedicated section on RAG in the next day of the training, but in short, it's really bringing in a data set. You're going to use Azure AI Search to create an index, and you're going to limit, you're going to set the boundary again if you want, or why not optimizing the model performance, right? Telling the large language model, like, you can provide an answer. I really want you to provide an answer, but the context itself can only be based on information from that custom data set. Another option is fine-tuning. What we're doing with fine-tuning is, I would say, closely the same as what you can do with prompt engineering, but a little bit more fine-tuned. And again, we have a dedicated section on that later on, and I'm going to walk you through some demos, how that actually works. And then ultimately, that's the upper right corner here. Why not combining all those strategies? So what it means is, in a full total spectrum, you're going to define as accurate, as close boundary possible, defining a system prompt. You're this kind of persona, you're this kind of solution engine, and you can only answer Azure technical questions. That was one of the examples I used in a training a couple of weeks ago, like almost replacing Peter as a technical trainer on Azure with the AI engine. Like, you're an Azure AI technical trainer, you can answer any questions related to Azure, but if some question comes up, like a prompt coming in that's not covering any Azure service, you are not allowed to answer it. Or you cannot just provide that answer, but you could also extend it, and that's where the fine-tuning comes in, where you can go like, well, you can respond in a polite way. You can reply with a joke. I want the output from my chat completion to be formulated in a table, for example. So that's where the fine-tuning is leaning a little bit more to the layout, if you want. What's the characteristic of my answer? Not the context of the answer, but what it actually looks like. It's formulated in a business context, or it's communication amongst friends with a little bit more funny, jokey twist. That's what the fine-tuning is doing. And then on top of that, obviously, you can still integrate your own data sets, not relying on the large language model, information from the public internet, but really bringing in the custom data sets. And combining all three, I think, is really what you're probably going to look into creating your custom copilots. I got a few slide placeholders here to make sure that you have a really good understanding what the prompt engineering is about, the fine-tuning is about, but I already set the scene on that. But nothing wrong with that. So in short, how can you apply prompt engineering? The first part is obviously just provide a question, what again we call prompt engineering. I like the phrase prompt artistry because it's really becoming an art. By the way, since I'm talking about prompts, let's try a little game here to really get you into that prompt mindset. If I say the word red, what's the first thing coming to mind? I can use my own brain as the large language model. And what I'm doing is thinking about an apple, a tomato, a Ferrari, or anything else that looks and feels like an object with a red color. Now, expanding my boundary a little bit, what if I say the word red vehicle? That's where now you might think about, it's not an apple, it's not a fruit, it's not a tomato anymore, because it's not a red vehicle. My Ferrari that I was thinking of before is still valid. But now my context is slightly different. And why not coming up with other answers like stoplights, a fire truck, ambulance, depending a bit on where you are in the world and obviously what color those vehicles have, but that could be a viable option. And then last, as the example, what if I say red emergency vehicle? That's where most probably Ferrari is not a good example anymore, but ambulance or fire truck would still be okay. And that's really what we're doing with the prompt artistry. You're going to define the context. You're also going to define the goal. My goal was stimulating your brain to provide the answer, fire truck or ambulance. But I need to help you getting there. And then the scoping is what your brain, what you as a human being know about the color red, know about a red vehicle, and knowing about red emergency vehicle. And obviously, if I would ask this to a different audience, like a 2-year-old kid or maybe a 20-year-old person, obviously the answer might be different. And that's also how that large language model is going to recognize your prompts. So that's an easy introduction, I would say, to prompt engineering. And I like the word prompt artistry. So the easy example here on the screenshot is just a question, write me a product description with a few details, but not super specific. And again, you know the goal of any large language model is providing an answer. No matter what, you ask me something and I'm going to reply. Well, now we're going to fine-tune it a little bit more. We're going to give more clear instructions. So we're still in that context of provide me a description for a water bottle, but now we're a little bit more specific. It needs to be 100% recyclable. It needs to be environment friendly. It needs to be super reusable and whatnot. That's where you define more instructions. You really augment that context. Next to that, you could also define the formatting. Like in this case, what we're doing is providing one line of context. I want you to translate something to English, and then within boundaries, like literally the dashes, you define the phrase, like in this case, what's the weather going to be like today, and it's translating. Now, the nice thing here is that we ask our language model to help me with something. Where now it's not what's the weather today, it's about translating that question or translating that phrase. And now the only thing it's doing is translating. Where now, depending on how you're going to build your solution, it might be just like a one-off prompt, like, okay, it's translated, cool, it's done. Or you could now move to chat completion. Now the difference, and I'll show you that later on, think back about our language models and the endpoints. If you think about the API endpoint, your connection from your application to the large language model using the model that you deployed, you connect to the API endpoint where it's connecting to /chat or /chat/completion. So that's an easy scenario, I would say, to really think about what is the use case for my application. And again, in this case, it might be like a one-off answer, or why not making it like a full chat completion, which I think is what most solutions actually look like. Another example is what we describe as using queues. What it means here in this example is I'm really defining the scoping, the context, the boundaries. This is about a SQL Server data retrieval question, and I want you to really provide me a query. Well, now it's recognizing it's about a query, it's about SQL, it's about combining tables, and I want to use the select statement. I can come up with a huge amount of other examples, and I'll walk you through some of these in my upcoming demo. But obviously, from my Azure background, I'm traditionally, and actually almost every day, at least multiple times a day, I'm using this to help me defining ARM templates, bicep templates, migrating ARM templates into, for example, bicep language. Out of my Azure DevOps and GitHub Actions background in the DevOps trainings that I deliver, I'm often using this as an example to help me really transforming, if you want, a GitHub Actions pipeline into a DevOps pipeline or the other way around. And if you think about like GitHub Copilot, one of the other examples, it's helping you in writing code for a lot of different development languages. And it's in the end all based on a combination of any of these examples that I talked about. Next to that, I also talked about grounding information, manipulating what the experience of your large language model and in the end your Copilot scenario looks like using the system message. So the system message always starts with you're an AI assistant and you can answer questions. That's really the baseline, what the AI service is helping you with. Well, now you can define a system message like the example I already shared. You are an AI engine and acting as a senior Azure technical trainer, and you can answer questions on Azure, could be everything in Azure, or you can only answer questions on Azure AI service specific topics. If I ask a question later on in chat about, can you explain what Azure networking looks like? Then the response will be like, well, although I'm an Azure technical trainer, I actually do not know the answer to that, or I'm maybe not allowed. And on top of the defining the system message, you can also use a few different manipulations. So one example here is the one or the few shot. What it means is you're going to add system message variables where you can define, like in this example here, you can only answer a yes or no question. Or in this case, it's about sentiment, like giving a few examples. if the phrase looks a little bit more positive, like awesome job, you are doing amazing, something like that, it's going to tell you the sentiment is positive. Where if I'm providing a system message, a variable example, like a sample sentence, like it's slowing down, it's not going fast enough, like a little bit more negative, it's going to tell me that the sentiment is obviously also negative. So that's the one or the few shot. Another really cool one is, I would say, really maxing out the potential of that large language model. It's what we call the chain of thought. So what it does here is really, I would say, even closer to human beings, mimicking like how a human brain is working. Like in this example, in the screenshot, it's about sports. We like to use this phrase as an example, where it's about what sport is easy to learn, but really hard to master. Where now it's not just about, oh, this is the sport. It's not just like this is the one and only sport option or category that we have. We're not even asking for, give me just a short answer. It's really about the reasoning behind it, where it's going to help you. And it's, again, just an example that I'll show you again later on in the live demo. But it's about giving you a set of potential sports which are super easy to learn. I cannot really help you with that because I'm not that good in a lot of different sport categories. I'm not good in any sport categories for that matter. But why not building a Copilot that actually will be capable to answer and help us with answering that question? And again, not just providing a short answer, but also explaining the reasoning behind it. Another example that I already mentioned was out of like GitHub Copilot, where in the end it's a Copilot. It has a huge amount of information, knowledge if you want, about how to write code, where now you could also use it to explain code. Why are you using this kind of models, not the large language models, but models in your development code syntax, for example, and it's going to explain to you in a pretty good way how to explain why it's actually using that kind of syntax. So actually really cool. With that, there's the last one, adding context. Already talked about it as well, but that's where you're going to define in the prompt, in the system message, creating more variables. You're going to, again, play, manipulate. And important, playing, I think, is a fun word, where you can imagine from here, we're going to shift to another demo, where I'm going to show you a couple of different aspects of the prompt engineering using the playground. That's the nice thing about it. And then fine-tuning, locking down, setting groundness if you want, how to differentiate using system messages, and based on the context of the system message, defining or experimenting with the completion of the output. So in this demo, it's all about using the prompts, the prompt engineering, the prompt artistry, as I like to call it, in the first part, and then the second part, how to interact with your custom Copilot using system message updates. So I'm going to repeat a few of the baseline steps from the previous demo, testing the chat integration, validating the large language model. So without changing anything, I could go something like, what can you do? About the same as before, like how can you help me? What can I expect from you? Where it's providing, again, a pretty generic description. I am an AI digital assistant, and I can help you with a multitude of tasks, answering questions, providing information, and anything else you can read from screen. Now, one of the first, I would say, configuration options you have in the prompting is literally telling the AI engine, like, I want you to take this kind of responsibility. Now, in this example, I'm going to imagine like my AI assistant, my custom Copilot, acting as a travel assistant. So I could now do something like, in my prompt, telling the AI interface or the AI engine, imagine you are a travel assistant, what can you help me with? Well, now it's going to recognize the prompt, and it's going to recognize what is the responsibility, what is the typical task set of a travel agent. So or a travel assistant, right? So as a travel assistant, I can help you with a pretty extensive list of scenarios, assisting with flight, hotel bookings, assisting with places to visit, and so on and so on. So just out of that prompt, I'm already defining the scope. Maybe we could call this groundness even. Like, I want you to do this, and from there, maybe you're not even allowed to do anything else. Another way to define the same responsibilities for our AI engine is not including it in the prompt, but using it as part of the system message. So I'm going to grab an example here on the side, and I'll make it a little bit bigger on this part. So what I'm doing now is updating the system message. So there is always, whenever you deploy the large language model, there is always this default system message, you are an AI assistant, and that's pretty much it. Where now I'm reusing some part of the prompt initially, but I'm moving it into the system message. So I'm defining you are an AI travel assistant, helping people planning the trips with certain objectives and some of the tasks you can rely on out of your application scenario. Important here when you update the system message is applying changes. We're going to confirm. And from here, I can now go back to my prompt, asking the same as before, what can you do? Well, now instead of coming back to me like I'm a generic AI assistant and I can help you with a lot of tasks, it's now coming up with a list of tasks it can help me with. So let's see how good our engine is, our travel assistant, and asking something about planning a trip to London. For now it knows that it's a travel agent or a travel assistant. It's going to help me, and it's nicely listing up some interesting, cool places that I could visit in London. We can extend the capability of our system message. We're going to keep the same thing, but now I want to play with the outcome. For now I'm going to add another little sentence here, answer with a maximum of 2 sentences. I'm going to update my system message. Remember, you need to apply. And then from here, we can repeat the same prompt. Well, now the answer should be a bit shorter than the previous one. Now, I find out that sometimes this is not immediately getting picked up. So the solution there is giving it a minute and then trying it again. But it looks like in this case, everything is working as expected, where now we have only 2 sentences instead of this interesting, but still factually correct bullet list of places to visit. One last example here in changing the system message is where we're going to add yet another little scoping. We're keeping the same as before, but now we want to look a little bit more in like the customer-friendly chat completion scenario, and we're going to define end your answer with a follow-up question. Saving the update, running the same question, so I'm going to copy the prompt from here. Where now it's still providing me the same answer, kept in a 2-sentence perspective, but now it's also adding, is there a specific type of activity, and so on and so on. So that's, I would say, one of the nicest but also easy examples to interact with your model. I tried something with the Prime Minister before, and I'm going to try it again. But it's still not exposing the date when the large language model got trained. But I would say I encourage you to play with the prompts a bit out of the chat playground yourself and trying to find out what would be the correct way to describe my prompt in trying to find out like what is the training date. And again, why is it so important? Because in the end, the large language models rely on information it got trained on from the public internet, where every now and then you could come up with a scenario where it's not really having information about the present day. Oh, let's try something different here. What is the weather like in Seattle today? It's a travel assistant, so I'm pretty sure it should come back with some information about the weather. But now here you can see that it's not capable of providing me any real-time access to weather information. And then it's still trying to be nice and helping me with, oh, I would recommend you checking like a reliable weather website, and then still loyal to my system message and with a follow-up question, like, is there anything else you want me to help with? So that's in short how you can use the chat playground using the prompt validation using system message. One last demo here is what I showed you as a screenshot in the presentation, where you can use the block sections. For example, something like, can you translate this sentence to French? Well, now we're going to add a breakpoint. We're going to add the actual phrase. What can I visit? Or let's do, where is the train station? Where is the central train station? I share my prompt into the backend, and it's now literally picking up the expectation, so translate a sentence to French, and it's going to recognize that little block section, where is the central station, and it's translating nicely to French. There we go. So that's pretty much it for this part of the demo. You learned about the system message, how to manipulate setting the ground if you want on the capabilities of the large language model. What do you expect the AI assistant to become to help you with? And then showing you only a few easy examples on how to interact from the prompt engineering perspective. So we did a lot of things, right? I hope that my examples in prompt engineering were helping you, like really seeing all the capabilities. Also touched on the system message manipulation, if you want, or really defining the options within the system message, adding the variables, defining the scoping. Where now the last part is, I would say, a little segue to our next day coming up about grounding. Now, I mentioned the word grounding, groundedness in my previous sessions already, where now it's really setting the scene, like, what do you actually mean by that? Now, grounding is really, I would say, defining, like, hey, large language model, I still want you to provide an answer, because again, you know that's the goal of what a large language model can help us with, using that natural language processing. But now you're going to define, where do you pick up the data from? That's in short what groundness is about. So I got one example, obviously on the left-hand side, where we're going to use our chat completion with ungrounded scenarios. Like, it just relies on the data that it's been trained on. Now, by the way, if we go back all the way to our conversation about different large language models, it also helps you with grounding. So one example, if you remember from a demo, is where the difference between, like what I showed you, GPT 3.5, GPT 4, there's obviously a few months, maybe years in between, but in this case, only a few months, right? But the timeline, like these are the public information data sets that the model has been trained on, is different across each version, which, by the way, could also be seen as a grounded feature. Now, in the example here, when I ask a question about some product, it's going to look into the backend, the public internet information that it knows about based on the fact that it's been trained on, and it's going to provide an answer. Where, again, every now and then, that answer might not be 100% accurate. Because again, the goal is, I need to provide an answer. And it doesn't always check. That's why we talked about this so many times already. We want to make sure that the answer it provides is as factual correct as possible. Unless you're going to ask for like a joke or something, then obviously it could be less important. Now, in a business context, you could say that you want to have as accurate information as possible. Even thinking a bit about outside of custom copilots, think about Copilot in Microsoft 365. One of the big options there is allowing you to interact with your corporate data. Yes, it's using Microsoft Graph, like the API calls behind the scenes, but it's going to expose information about your organization. Using Copilot in Teams, it's going to look at a recorded meeting, and it's going to provide you a summary. It's going to show you like who were the presenters, the people inside the call asking questions, stuff like that. And it also allows you to provide a summary in like 5 bullet points, and maybe you could go as far as provide me any action items for me as one of the participants in that meeting. That's the groundedness. Where now in our M365 example, it's Microsoft Graph, it's connecting to your corporate Microsoft 365 data. We're now in a custom Copilot scenario. You need to bring in your own data sets. Now, a data set can be a lot of different options. You can upload files. One of the examples I'll show you later on. You can upload files, and obviously you can upload folders in a multiple file scenario. Can be text files, can be PDF documents, can be Word files, can be pretty much anything. You can connect it to Azure Blob Storage, you can connect it to Data Lake, and for the more advanced scenarios that I'll talk about in day 2, when we touch on the RAG scenarios, the Retrieval-Augmented Generation, you could also interact with vector-based data sets where you might connect to like a Cosmos database and a few other examples. Now, the core here is that you want to integrate custom data, your own data sets. Like in our example here, when I'm asking about the same question about product XYZ, I now don't want the large language model to go out and come up with an answer based on public available information, but only using information from my data set. Now, the way to do that, again, the solution is called RAG-defined solutions, or we're going to develop a RAG-based custom copilot. So what RAG is doing is bringing in all the beauty from a large language model, like the real core aspect of that large language model, having access to data, but also recognizing the prompts, like the natural language processing, analyzing the data, retrieving, finding the data, and then augmenting it. And that's the nice thing about the concept or the definition. It's retrieving information, it's augmenting using the large language model capabilities, like fine-tuning the prompts based on system messages, based on the prompt engineering aspects that I talked about before, and eventually generating a super contextualized, actual fact-based answer based on the data set. Obviously, the data set is now becoming your prime source of truth. It could also become a bottleneck. If I'm asking a question about product XYZ, but that information is not available in my data set, obviously my Copilot won't be able to answer that question. So you still need to manipulate the system prompt a little bit in this case, where it's going to tell you like, oh, too bad, I could not find that specific product information. But then also using the large language model capabilities, it might recognize like, oh, it fits in this specific category, and maybe I can offer you some other product offerings. So the core capability of the large language model, recognizing the prompt, looking for an answer, is still there. We also talked about fine-tuning models, right? Now, fine-tuning that model, again, is not really about changing the data. It's not about manipulating the answer, but it's a lot more about how do I provide the output. So I describe it as you're fine-tuning the style of the output. Present it to me in a table. Provide me like lyrics that I could use for a song. Tell me a joke. Tell me, help me composing an email or some business letter in a business context. How do I approach a difficult message to my manager, for example? So that's where it's again reusing the core of the large language model. It's going to help you composing that letter or that email body, and then recognizing like it needs to be in a business context. It's not talking to your friends. It's not translating it into a joke, but it's really setting the boundaries on that business context towards your manager, and then helping you formulating the context of the letter in a specific output. And that's really what the fine-tuning is about. Now, how do you actually do that? Like, how does this all work from like a little bit of a developing perspective? Well, the easy answer here is you're going to use what we call a JSON-L or a JSON lines file. Now, the JSON file itself, first of all, it's obviously you're reusing everything from JSON. So you got the curly braces, you got the commas, you got the actual sentences in between, like the actual data. But apart from that, it also needs 3 specific components. Any JSON line that you're going to add in your file needs a system message. You already know what a system message is about, and you're going to provide it to that platform. In this example here, but I'll bring something else in my demo, this is about an Xbox customer support agent where you're going to ask some questions. So you're going to tell like, hey, my dear Copilot, you're an Xbox customer support engineer, and you're allowed to do this and that, and you can only provide factual query answers to queries and not providing any answers outside of Xbox. Next to that, you're going to define the user message. You're providing examples to your large language model engine, like this is the context, the system message, where now you have a prompt example. Where now this prompt example is Xbox better than PlayStation? And then ultimately, you also going to provide an assistant answer. You're an Xbox support engineer, you can only answer questions about Xbox. Obviously, the question here, the user message is not really Xbox related, and then you can formulate what the answer actually looks like. And in this case, it's doing a pretty good, but also nice behaving job, telling like, oh, too bad, my prime job is in the Xbox space, and I'm not really capable of answering. But then also closing with a follow-up question. And that's, if you think about, again, customer chat-alike conversations, I'm not really able to answer this specific question, but since it's a customer support context, you do not want to lose that customer. You don't want to disconnect the chat conversation. And you're going to try and please the customer, or maybe the potential customer, if it's not a customer yet. Where now you're going to try and like, oh, well, I couldn't answer this, but I'm going to try and help you with something else. Or the example from before, like I cannot find anything about that specific product you asked me for, but maybe I can offer you another product. And even if you think totally outside of like AI and chat conversations, it's just how natural customer business relationships are working. You walked into a store. I know maybe for some of you, it's been a while since you actually did that. You're looking for information. They're going to try and help you. And I'm like, oh, I'm looking for a blue shirt. Oh, too bad. We don't have blue, but we got green and pink and all the other colors. And would you like to try one? That's like the typical behavior, I would say. We're now out of the chat conversations, out of the fine-tuning. We're still helping to really move into that AI-inspired, AI-influenced, awesome custom Copilot scenario. Enough about talking how to do it. Let's jump in this last demo for today, where I'm going to show you what it takes to fine-tune your model. So let me show you what it takes to actually deploy a fine-tuned model in this next demo. So I'm still obviously, again, in my hub, in my project, and within my project options here on the side, I'm now deciding to go for fine-tuning. So we're going to deploy a model, and the way to do this is almost the same as just deploying the traditional large language model from the model catalog. As you know, we deployed GPT-3.5 before, which means it's one of the models that's open for fine-tuning. I picked my model, and I'm going to add a little suffix. Now we're still in that travel mindset, like building a travel assistant, custom Copilot. I'm going to link it. I click next, where now the idea is to open up our training data. Now there's a few different options to provide information. Remember, it needs to be in that JSON list file, and I'll show you maybe while the deployment is running what that JSON file actually looks like. Now there's a few different training data sources you can select. You might already have data in Azure AI Studio, where it's maybe coming from your data scientists team out of the machine learning portals that you used before, and it means that you can immediately reuse it. For this demo, I'm going to show you how easy it is to actually upload a new file from scratch. So I got this file on my local machine. I'm going to select my travel fine-tune. And the other nice thing, actually, I don't really need to open the file itself, because there's a little validation of the data where it's going to show you the actual content. So this takes a couple of seconds. Well, now if I move down here a little bit, it actually shows me the content of that file. Now I'm going to zoom in a little bit here to briefly explain a bit what that file structure looks like. So the baseline is a JSON file. That's what you recognize with the curly braces. And we always start with 3 different components. In any chat conversation, like the custom Copilot chat conversation scenario we're building here, we always define a system message. And remember, in previous demos and session, we talked about system message. Next to that, you specify the actual system message. So in our case, it's the exact same description what I used before in the live demo. It's an AI travel assistant. Then moving it a little bit to the side, which it doesn't like to do. I'm waiting for that little balloon to come up. There we go. We also have role user content, and that's where the user is representing the prompt input. So that's where I do have a question here. What's a must-see in Paris? And then a little bit further, but it's getting a bit off screen, I do have my actual role user content, where now it's providing me the role assistant content, helping me providing a predefined answer. Because in the end, what we're trying to do with the fine-tuning is really locking down what can my AI assistant act like, in this case, the travel AI assistant, and what is the data set it's going to use. I don't need to validate the data, but that's one of the options we have. And everything else looks quite okay, so I just click next, and I'm going to submit my deployment task. Now, the fine-tuning, processing work, as well as the deployment, might take a little bit of time. So I'm just going to wait for this to complete. So before showing you how to actually move on from here, I want to highlight a few things out of the fine-tuning process itself and how you can do a little bit of monitoring as well, by the way. So just to give you a little bit of a heads up what we did, we have that JSON file with a couple of examples, like show me something that's interesting to visit in Paris or London or any other prompt that you have. You build up that sample file, and from there you're going to upload it, and you're going to use that as the fine-tuning of your model. Now, the fine-tuning is still based on a full LLM. So we start with deploying the model. Like in our case, we deployed GPT 3.5 and then hooking into the fine-tuning of that one. Now, after that process, and you can see even for our 15 lines of example in our fine-tuning model, it took close to an hour to actually complete that task. Now, you can manipulate the timing a little bit. You can add more compute power. You can define more tokens, less tokens. It's, I would say, a little bit limited in our demo environments. Now, more important is, again, the link to our training file. So remember, we have different options. You can upload the file, the example I used before. You can define the training tokens used, where obviously it has impact on the quota of your subscriptions. You can download the results. I might do that later on for troubleshooting, maybe for, why not, picking up this fine-tuning export, using it as an import for the next cycle. There's a section here for metrics. Now, there's not too much information here, but what it mainly picks up is the loss and token accuracy. Now, the loss is really identifying, like out of X amount of items in my JSON file, how many of them are maybe not that accurate. So this could identify like some wrong data in your data set, or maybe on purpose you're going to inject something weird to test how well the fine-tuning is working. Then the token accuracy is about the same, where it's going to highlight like the how many tokens it's going to use to actually train that model. So it might not always be that important, but I would say pretty cool that it's integrated in our fine-tuning scenario. Then logging, I think, is also always a relevant one. And I would say some of the interesting parts that I'm going to highlight is obviously the starting point. So we started this some time ago. The pre-processing starts, the job starts, and that's where the training kicks off. Every now and then, I've seen some error messages showing up at the start of the job where I have to remind you about the RBAC permissions. Remember, we configured a managed identity, giving it access to the storage account. If you deployed it in the way I showed you in one of the first sessions and demos, everything should be quite okay. But imagine that you connect a new AI service to an already existing storage account. It might be that the permissions to actually reach out to the file on storage is not working as it should be because you do not have the permissions as being the AI service. And that's where sometimes you get this weird error message that you're not having authority to connect to the data set. And then from there, it starts running the fine-tuning process, step 1, step 2, all the way to step 100. And that's obviously where most of the time is getting used to really process and analyze the data. And then eventually we have our job successful and we have that result file. And then last we have checkpoints. Now checkpoints are also quite interesting. So as you can see, after about 80% of the task being complete, it has a pretty good idea about the correctness of the data that it needs for the fine-tuning, and it's going to create a snapshot. Now the nice thing is that from here, you can select the snapshot and actually using this as a deployment. Because in the end, what we did so far is just building another deployment model. So you could say it's like recognizing everything from the large language model, like in our case again, the GPT 3.5 as the baseline, and then adding the specific fine-tuning options that come from that JSON file in our example. So it still recognizes it's an LLM, but it's like a subset, a stripped-down version of that. And next to that, it also still accepts the natural language processing. So what you would do from here, the fine-tuning is complete. Even if you go back to the home page, you click deploy, and it's going to allow you to deploy it. Now, I told you with all the demos I'm doing, I'm maxing out some of my AI quota. So I'm going to go back to another scenario where I already deployed the exact same thing. From here, the deployment is pretty straightforward. You already know how to deploy the model because that's what we talked about a couple of demos back. Ultimately, the outcome is when I'm running my chat conversation, remember I showed you that JSON file where one of the questions, the prompts came up is, what's a must-see in Paris? Where now the chat completion, the answer that we get back is literally now not coming from public internet information that we used with the training of the GPT 3.5 model, but it's now exactly the phrase coming up from what's in our fine-tuned data set. I think this completes the fine-tuning section. Now there's one last thing I'm going to highlight, and that's continual fine-tuning. What it's allowing you to do here is actually going back to another fine-tuning run. Now the mindset is not like, oh, maybe the first fine-tuning is not good enough, I'm going to run it again. Obviously, when something went wrong, that's what you're going to do. But the idea is here that you can now create variations. You can bring in slightly different metrics, or even using like the checkpoints I talked about, where you go like, well, I'm going to start with the checkpoint 80% complete, and I'm going to add some adaptations to it and using that as a new fine-tuning model. So almost creating a cascade scenario of different fine-tuning models. You're going to revise it a little bit. You're going to make small modifications. You're going to add some improvements. And then from there, running that model performance again. And you could obviously repeat the whole process. You could change the source data set to continuously test and fine-tune even more, all the way to the fact that you have this, like in our example, remember, we're trying to build some sort of a travel assistant where now we want to lock down what can be used as an answer. Where now it means that it's not going to come up with everything from Paris, like what's to visit there, but the highlights that you want to integrate. Translating it to like maybe a retail example, if somebody would ask a prompt like, oh, can you tell me something about product XYZ? Then obviously you want to make sure that the information is coming in correct. So with that, let's move on with the next part of the presentation because we got a lot more to still cover. Thank you for now. This concludes our session. Now, there are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.